For this lab, our materials that we used were the steel plates and also the electrodes for welding, also as the machine used to the welding machine. Also, we use all the equipment needed and all the materials needed to make the beaker's hardness test, that is in the microscopic level, including all the steps from the polishing of the bakelite, producing the bakelite, making the chemical attack, and all of those steps that we already seen in the previous course.
Well, during this practice, we first did a cut of a metal plate into two, and then we did the welding process. And then we cut it in two small pieces in the core section to be able to do the metallographic procedure, to be able to use a beaker's machine to do the micro hardness test, and be able to obtain all the micrographs of the.
After all the procedure that we did, we obtained some data that help us to conclude what happened with this practice. First, we have the beaker test we did in the welding zone. This is the first one, and it's the closest to the welding zone, and this is the last one, and it's the furthest to the welding zone. We can see that here we got 182 beaker test hardness, and this 154. We can see that the hardness reduce when we will get further of the welding zone. This is the normal beaker hardness that we obtain, and we can see that it's like an average like 170. And finally, we did the micrographic test, and we obtained these results. First, in the welding zone, we obtained 32 grains and 12.64 ASTM, and in the normal steel, we got 8 grains and 10.64 ASTM grain size. With this, we can conclude that our material, when we make the welding process, the grain size reduce significantly, and because of that, the hardness will increase in our material. If we want to get the same properties, we have to make we must make a thermal process.
One of the advantages that we can obtain by welding two metals is that you can join these two pieces at an atomic level, which means that the atoms of one piece have fused with the atoms of the other piece. One of the disadvantages is that when you do this, you change the properties of your metal. So if you needed it to have very specific properties, then your metal will change. When you weld, many structural changes are expected. One, when the metal is liquid and it solidifies again, what happens is that the structure changes, so the grain size becomes smaller, giving it better properties. It's more hard, and because the grain size is smaller than it was before.
In this lab practice, we learned that welding is a really important stage for the industry, because it fuses both metals, and also because welding is really common in steel, and since we've seen in class that steel is really important in the industry, we as mechanical engineers must learn about this process, because it changes a lot in the mechanical properties and also in the microstructure. So it was really important for our formation as mechanical engineers, and it was important of the solidification theme that we are seeing in class.
After realizing this practice, we can conclude that welding is a process that is very helpful for many processes, like joining two pipes. Many times we think that when you join two things, maybe the joint is going to be weaker than the actual material, but we discovered with this practice that when you weld, you actually get better properties in your material, and if you need the same properties in all the material, you can just apply a heat treatment So I think it's very helpful to know this information.
Well, during this practice, we learned basically that when we would do welding processes, all the mechanical properties, they get improved in many aspects. So basically, we learn how in the industry this process is really interesting and really helpful to create better mechanical properties for the materials. Thank you.
With this practice, we learn how the welding process is a really useful procedure that can help us to fix our material if it have something wrong, like a cavity or a pipe. Also, that the welding process increase the mechanical properties of our material and how this can affect to our application.